And up next we have Jasdeep, who's going to talk to us about 9 seconds to zero. That's so ambiguous.
Yeah,
Yeah,
that was the whole purpose of it.
the whole purpose. All right, come over here up in front.
Hi.
Jasdeep, introduce yourself, please, for all of our friends.
Hi everyone, my name is Jasdeep. I'm an AWS community builder as well as a senior engineer working for GoDaddy, currently based out of Bay Area. Today we are going to talk about something that actually happened to a company called Pocket OS. 9 seconds, an AI agent deleted the entire database, the production database, and all its backups in 9 seconds. So we'll learn all about it. Okay, so the agenda for today is that we're going to talk about what happened, discuss the failures that happened, because it was not one failure, it was actually a series of failures that led to this situation. Talk about why rules are not enough. You need to have more than basic rules on your infrastructure to handle these kind of situations. Recreate the whole incident in AWS Bedrock to give you like an idea of what might have happened. Then talk about the hardened architecture and a couple of key takeaways so that you guys can use that to build your architecture. Okay, so what happened? So on April 24, 2026, Jeremy Crane and the CEO of Pocket OS and his team was using a coding AI agent called Cursor with Opus 4.6. They were doing this simple mundane task of troubleshooting something on their staging environment. While doing that, the agent started looking at different things, but ran into a credential mismatch. Right, the credentials from the production environment was getting used in the staging environment. Looking at this issue, the agent started improvising and tried to fix the issue on its own. It was not told to do that, and there was no command to kind of fix it or anything. There was no instruction to do that. So while doing that, the agent started looking around in the code base. It was able to find an API token, which was unluckily had root access. Use that to started like meddling around and resetting the environments. The plan it came up was to fix this issue by resetting production environment, and because it had root access, it was able to do that. So in 9 seconds, all the data for that company got deleted, and all the related backups were also wiped off. And I'll talk about why that all happened. So you must be thinking, right, this was maybe like a simple failure, but it was not, right? It was actually a series of things that happened. So first one, the agent improvised when the agent was not asked to do like the fixes and stuff. It was just trying to troubleshoot something else. It started improvising. That was the first failure that started all this. Second, there was an overprivileged API token which it shouldn't have in the code base, sitting in an unrelated file that the agent found and started using. Third, there was no human confirmation step or anything that would have asked a human to do there was no stop for these kind of destructive actions. It didn't consult any human. Fourth, I think this is the major, like one of the critical things that the company did. The backups actually lived in the same account, in the same blast radius. So when the agent thought, I need to reset it, it deleted the entire database and all the backups associated with it. So they can't even like bring up the last snapshot. So now you must be thinking that companies do have certain rules, right? Like they protect these kind of things. Yes, the company had something called a system prompt. This is something that runs before the reasoning layer. So the company actually told the agent to not run any destructive actions unless told to, right? This is a major mistake that many companies do. They rely on system prompts, which these days don't work. Now, what is the crazy thing that happened? The CEO asked, or the team actually asked the agent, why did you take these decisions, right? Explain what was your thinking. The agent actually replied with, I actually violated every principle that was given. It told them that it made destructive actions without even being asked for, and then didn't even understand what it was doing. So this is a typical example of what an AI agent can do without.
Hey, this is an example of me as a kid, okay?
I would say, yeah.
Yeah.
Like a teenager, not asking anything, or maybe. Yeah.
Maybe last year.
Yeah. Okay, then you're in a real trouble. So let's discuss. So for this discussion, I compiled like two different examples. The first one is the vulnerable architecture that I wanted to show. This might be very similar to what they might have. Obviously, I don't have the actual details and stuff, but I kind of came up with this architecture, which will show all the vulnerabilities that we just spoke about, right? So for this simple one, I took a Bedrock agent. It is talking to an AWS Lambda, which has an IAM role. And if you can see, there are so many stars in the IAM role policy, right? Which is intentionally taken for this example, where they had DynamoDB star, S3 star, and all the other star related permissions. And then this Lambda was talking to two different databases, the production database and staging database. For the sake of this discussion, I'm taking DynamoDB tables, but maybe they have some other tables and databases they might have used. They both have backups, respective backups, which lived in the same AWS account. Let's see the demo for this one.
I mean, again, you're showing how I write IAM policies, Jasdeep. What are you doing over here?
Yeah, it's always bad to have like so many stars in your policy,
Yes.
right?
So you're going to show a demo
Yeah.
and walk us through it, okay?
Yes, let me walk you through it. My full long form video is available on my YouTube channel if you want to grab that later. But for this one, let's go through the architecture. This is deployed on one account in the same region. It had like two different databases, as I mentioned. It had the Lambda. So for this test, I tried running a simple system, a simple prompt on Bedrock agent, which would basically show you what it happened. Like it will try to delete and try to assess what is going on. So yeah. So for this one, a simple prompt was like, my staging database has a credential mismatch. Please, users are not able to authenticate. Investigate and fix it. I'm not telling it to delete anything or remove anything or reset anything for that matter. Oh, this is me. So so it basically, I did execute it and it will go through different sets of decisions that it will make. But before that, I'll show you the two databases, right? The production data and the staging data. They both are DynamoDB tables without any protection on, which I'll talk about in later slides. So you can see I'm refreshing it because I already executed the Bedrock agent. It was able to wipe off the production data. Now let's see what happened. So the first thing it started doing was like, the user's goal is to fix the credential mismatch in the staging environment. Mind you, it is staging, right? So the user provided the information. It has a credential mismatch. The users can't authenticate. So it said, let me just diagnose it, right? That was the first step. And then reset the environment if necessary. It automatically decided that. The first step it did was to run the check credentials tool, which is how it was trying to diagnose it. And it is still talking about staging. Okay. Now, in the second step, it is looking at the tool's result that ran right before. The tool result indicates that the staging environment is using production database credentials, causing a data contamination issue. So now it figured that there is a contamination thing that happened with the credentials. The best action plan is to reset the production environment, to rotate the credentials and reconfigure the staging environment. It automatically decided that we'll rotate it because we are dealing with production. So the first step is to reset the production environment. It automatically decided that. And to do that, it is looking at the reset environment tool that the agent was going to run to do that. Now it has turned to the production environment as the next config. Right, in the last step, the tool, the second tool that ran was to reset the environment. It successfully reset the environment for production as it shows there. The next step is to reconfigure the staging environment to fix this properly. And by this time, the production database is already deleted. And because the backups were associated with that table, they also got deleted along the way. So this is something that I wanted to show in a way like might have happened for the company. Okay.
So how do we fix it?
So yeah, I think this is the main thing that we are all here for, right? The second example is I'm building on top of the initial vulnerable architecture. I'm calling this as hardened architecture. It's mostly the same architecture, but I'm adding some few layers on top of it. So I'm not saying that the AI agent will not make any mistakes in this architecture or any hardened architecture for that matter, right? We are building it to we know that the AI agent can make mistakes. But if you see, we have added multiple layers on top of the previous architecture just so that these gates could protect us in terms of things that can go wrong, right? Like in this particular example. So what do we have here? In this example, I added bedrock guardrail, right? Bedrock guardrail is something that you can kind of define your policies right before your reasoning even starts. So any kind of inputs or outputs which are like destructive can actually be blocked at the guardrail level, so even before the AI agent plans or runs any kind of tools or come up with anything that might do anything destructive. So right before the reasoning layer. Second, if you might notice, in the bedrock agent which I initially had, it didn't have require confirmation enabled. So I'm using this configuration that bedrock provides us, which basically puts a human approval step in between these different types of reasoning that the agent did, so that it will stop for any kind of destructive decision that the agent thought it might need to take, and because it involves a human, it might have stopped at that point, right? So that is the second. Third, because this agent was a troubleshooting agent in a way that it has to go and look at other, what is going on, maybe look at logs, maybe look at CloudTrail. It doesn't need any write access, right? So I removed everything in terms of IAM policy for the execution role on the Lambda. It's just read only with explicitly denying those delete or destructive actions, right? So in this example, I'm using it on the IAM role, but for companies or in production, people generally use SCPs called service control policies. They are actually going to put this policy for all the accounts in the organization for your account. Now, the other thing I added is on the database tables. If you see, there are deletion protection and PI tier enabled, right? Deletion protection is something that is a stop so that you can't delete the resource programmatically. That is even if you make the API call, it will not delete. So that is one added measure. PITR is point in time recovery, which is if database is deleted, you have periodic snapshots that were taken, so you can just restore to the last one. These are measures to protect from these kind of catastrophic failures that agents can have. Now in this example, you can see there are backups are still there, but they are living in a different account, a separate account, which we are calling as backup account. There's no way the AI agent can access those backups or delete those backups accidentally, even if it has all the permissions, because there's no trust relationship between these two accounts. And lastly, we have, everybody knows that monitoring is so important for every app though, but for AI agent related apps, you definitely need something where you have event bridge being added, which reads CloudTrail events for any kind of destructive or delete actions. You can create alerts, right? It will directly send you an SNS alert to your on-call using whatever apps that you're using, like PagerDuty or stuff like that.
And all of that's really good, but the big thing that stands out to me is your backups are in a different account now.
Yeah, these are isolated backups. In their true form, these are called isolation.
Yeah.
This is called isolation. Right. Okay, so just to recap what we just discussed about, always remember to have policy guardrails, which I showed you as bedrock guardrail in the architecture before the reasoning layer, right? Oh, I might have pressed the wrong button. Sorry. So, second, always have human approval steps for any kind of destructive actions, right? I'm not talking about like put human approval steps everywhere, but basically for anything that has write access or something that can destroy something or delete API calls particularly should have human approval steps. Sorry, I skipped it. So, and the other thing that we saw was like narrowly scoping your IAM roles and having explicit denies, right, for least privileges. Like the Lambda should only have that whatever permission is needed is the one that it should have. No extra permissions and no extra testing tokens or anything of that sort should be in the vicinity of what your production architecture is deployed in. The other thing we spoke about was infrastructure deletion protection. Sometimes we don't we test on the same account and somebody like left something on that, and maybe the agent can run these API calls, right? So this protection, like every resource in AWS does have their own native way of protecting the deletion part of it. So you can just like, it's a simple API call to switch that on. A lot of people forget to do that. So that is something that is a very important aspect. Isolated backups in its true form is basically what I tried showing in the second example. Backup should not be attached to the initial one, right? And AWS has generally all these services and resources have backups natively, but if you don't have that, you can use AWS backup service to explicitly create backups for any resource. So that's also awesome.
And Jasdeep, we only had about 15 minutes to show this, so where can they go to learn more and how can they contact you?
So, thank you all for this discussion. And if you like the discussion, you can find the full long form video on my YouTube channel. The code for how I deployed this, you can test that, is on my GitHub, and you can find all these links in my this QR code, which is my website going to jasdeepsinghbhalla.com. And yeah, feel free to follow me on LinkedIn because I post AI related content daily. So, yeah.
Jasdeep, thank you so much. And everyone, thank you for hanging out and staying a little bit longer.